Hello everyone, we're going to be doing vector valued functions today for Calc 3. No actual calculus yet, that's actually going to be next lesson, but right now we're just going to be doing vector valued functions. So we know scalar valued functions already, that's just something like f of x or f of x comma y. You plug in some numbers and then you get a number out. You plug in scalars, you get a scalar out as well. But vector valued functions, something like that, that's how you denote them, with a little vector hat. You put in a scalar, like a t value, I don't know, t equals 1, and then you're going to get out a vector, right? One simple example we saw is anything that follows like the formula r of t equals t times v plus r naught, right? Because you plug in a t value, you multiply that t value by a vector, and you add it to another vector, you're going to get, you plug in a scalar, and you get a vector out. So this is really like already a vector valued function that we've seen. But we're going to be looking at some more complex ones. One thing I think is kind of helps me, because I remember first learning about these, I was a little bit confused about how we get vectors out of this. What's really happening is if you have some r of t and then you have 3D space, and you plug in some r's and you get, I don't know, you get like a line like that, I don't know, something like that. What's really happening is for each of these t values that give us this line, you're getting a vector that points here, 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 etc. But we only interpret this as where the tips of the vectors are hitting. Okay, and we're going to see that later, and with an animation as well on Desmos. So let's see. Now, one really basic and important one you should know is just r of t equals cosine t, comma sine t, comma 0. So each of these, what this means, I know it's a little bit different than how we learned them earlier, but this is just the x, this is the y, this is the z. So for this function, x equals cosine t, y equals sine t, and z equals 0. To figure out what this is, you could just plot it, right? If you were to plot this, you'd be like, oh, okay, t equals 1, what am I gonna, or t equals 0, what are we gonna get out of that? We're gonna get 1, 0, 0, right? So that's here, we'll say. If you put t equals pi over 2, cosine of pi over 2, that's gonna be 0, sine of pi over 2, that's 1, this is still just 0, so you're gonna be right there. T equals root 2 over 2, we're going to get something like that. If you do this to all the points around, you could see that you're going to get a circle. And z is always equal to 0, so this guy's, he's in the xy plane. This circle of radius 1, he's in the xy plane. Now, you're going to get different radius circles if you change the coefficients of these guys. Oh wait, before we move on to here, let me just make a comment about this. You could also get this result by making some kind of statement that's true about, that like kind of relates all the values in here and is true. So a true statement we could make here is that cosine squared t plus sine squared t equals 1, right? That's just an identity. And then we have this little table right here. It tells us x is cosine t, and then y is sine t, so that we could rewrite this as x squared plus y squared equals 1. And that's another way we can get that equation for a circle of radius 1 in the xy plane. Now, if you gave these guys like coefficients that aren't 1, so like 2 cosine t, and then 2 sine t, comma 0, you'll do the same procedure and see what radius you're going to get. So you're just going to get 4 cosine squared t plus 4 sine squared t. You could factor out a 4. So you're going to get 4 times sine squared t plus cosine squared t, which equals 4, right? So here you have x squared plus y squared equals 4, and this is just a circle of radius 2, right? So yeah, you could also make ellipses like this, like if you just had r of t equals cosine t and then 2 sine t, right? Then you're just going to have an ellipse, right? So at t equals 0, you're going to have 1, 0, but at t equals pi over 2, you're going to have 0, 2. So like somewhere there, you get an ellipse, some sort. Right. So yeah. Okay. Another one that's pretty important, but looks kind of similar to the ones we just looked at, is going to be r of t is equal to cosine t, comma sine t, comma t. Now, the only difference, and kind of a big difference here, is that our z value is no longer 0. It's t. I mean, I guess it could be 0 if t is 0, but you get the idea. It's not 0 for all values of t. It changes. So what we're going to have is, I guess the best way that I imagine what comes out of this is kind of like its xy shadow, which is like its trace. So if I only looked at, if I looked down like the z-axis, I would only see cosine t and sine t, and we know that that's a circle, right? So if, like, I don't know, you were looking down here, those are your eyelashes, right? So you're looking down there, you would see like a shadow of like a circle, right? But that's when z is 0 for all values of t. But that's not the case. Z is equal to t. So at t equals 1, we're going to be at z equals 1. At t equals 0, we're going to be at z equals 0. And it's going to vary, right? It's going to go up and up and up. And the only way we could get this kind of outcome, where if we look down it, we're going to get a circle of radius 1, is if we have like a coil. Okay, holy shit, I'm terrible at drawing. Something like that, right? And then we could observe this. And just a reminder, these points are all the tips of vectors that we get out of plugging in this function. So we have like all these vectors that are coming out, pointing at those points. And here's what animation I was talking about. This is exactly the graph we just plotted, and then that green vector is what's like pointing to the point we're going to be sitting at. So yeah, and then if we look at it from the top, we see a circle of radius 1, right? So yeah, it's kind of neat. Okay. Okay. And then another important one to know is this guy. So R of t is t cosine t, comma t sine t, or sorry, well, it doesn't really matter, comma t, right? So you could simplify this guy again by just doing the identity. You're going to get t cosine t squared plus t sine t squared. This equals t squared times cosine squared t plus sine squared t, which just equals t squared. So t squared is just, this is z squared, right? So you could rewrite this as x squared plus y squared equals z squared. This is something we've seen before. This is just a cone. This is like, it's just one of these guys, right? If you look at them, oops, terrible. If you look at them from the top, from the xy, it's just a circle that changes sizes with z changing. And then if you look at them from the xz or the yz, you get these crossing lines right here, these guys. So yeah, that's how you get that guy. Okay, now let's just do like a quick little example. Okay, so let's find where the coil we found earlier. So R of t equals cosine t, comma sine t, comma t. We want to find where this guy intersects x squared plus y squared plus z squared equals 9. So let's identify these. So we know that this guy is like a coil. And we know that this is a sphere with a radius of 3. So if we drew this out, we have like a coil, I don't know, and then we have like a sphere, right? If we keep drawing the coil, we see that it should intersect at 2 points. That makes pretty logical sense. Now how do we go about finding these? So it's literally as simple as plugging in. So we know that x is equal to cosine t, y is equal to sine t, and t is equal to z. So if you plug them in, you're going to get cosine squared t plus sine squared t plus t squared equals 9. These guys are just 1. So you have 1 plus t squared equals 9. T squared equals 8. So t equals plus or minus root 8. And from this, we're going to get 2 points, kind of like how we drew it out. So let's do r of positive root 8. That's going to give you cosine of root 8, sine of root 8, and 8. And then, just root 8. And then r of negative root 8 is going to equal cosine of negative root 8, sine of negative root 8, and then just negative root 8, right? And then I guess we could plot this, make sure that we're not wrong. X squared plus y squared plus z squared equals 9. And then plot those points out. So yep. So that's the point we got, the purple point. So obviously if we did a negative, then we would get like a negative down here as well. But yeah, we get the idea. Okay. Now another important thing that's pretty easy that they like to ask questions about is just the domain of a vector valued function. It's kind of hard to explain just with words how you find this domain. I think it's easier if we look at an example. So if they ask you like, oh, find the domain of this guy right here, r of t equals x squared, or not plus, comma 1 over x, comma square root of x, you would, how I do this is I just go from left to right. So for x squared, our domain is literally just all real numbers. Just all of this. Okay? And then for 1 over x, it's everything but 0. So if 0 is right here, it's everything but 0. And then for root x, it's everything that's positive, including 0. Alright, well, it doesn't include this, my bad. This is what it doesn't include, but it includes all this. 0 and onwards. So we have to look at what they all share. And in this case, what they all share is everything that's positive past 0. So everything that's in here. Right, so our domain for this guy is going to be 0 to infinity. Right? If you plug in 0, this is going to be an issue. Yeah, anything greater than 0, you could plug it into all of them. So, yeah, you just look at where they all share. Okay, so now we could move on to some practice problems. This one's also not the longest video. I think the ones that are more intuitive aren't too bad. And again, this is more of like a lecture review rather than a total lecture. Okay. So this first question is from Spring 2024, Exam 1, Question 2. So that's just, where is this continuous? This is ln of t squared. That doesn't really change anything though. So if we look at ln of t, or yeah, this function itself takes in anything that's greater than 0. So anything that's here, okay? So this whole function, that means it doesn't include 0 because this guy can't take 0. So that crosses out A and C. Okay, now we're, oh yeah, and that also crosses out E because 0 is between these guys. And we can't plug in 0. And we also can't plug in any negative numbers because of the square root. Okay, now, is it 1 and onwards, or 0 and onwards? Or just anything after 0? Well, I don't know. Can you plug in 0.5 into all of these? You can. There's a square root for 0.5. You can plug in any positive value into ln. And same with cosine. You could plug in stuff that's less than 1 into cosine. So that means it is not D, because we could plug in stuff that's outside of this range and still get vectors. So that leaves us with B as our answer. So that is the right answer. Okay, this next one is kind of different because it does deal with lines, but it deals with points of intersection, which is kind of interesting to deal with. So what value of A do R of T equals 1 plus T, T, and 1 plus T, and R of S, which equals 2 minus S, S plus 1, and 2S plus A, intersect at one point? So for these guys to intersect, that means they share an XYZ point. That means this guy's X is equal to this guy's X, this Y is equal to this Y, and this Z is equal to this Z. So you just do 1 plus T equals 2 minus S, T equals S plus 1, and then 1 plus T equals 2S plus A. Okay, so now what you could do is, so yeah, all we did right now was just equate them. Nothing crazy. We equated the X of one guy to the X of the other, Y of one to, yeah, you get the idea. Sometimes they might trick you and put this guy as T as well, but you will have to treat them as two different parameters. Otherwise you're gonna get confused with what belongs to what, and you're probably gonna cancel out the wrong things. So it tells us here that T is equal to S plus 1, so you could rewrite this guy as 1 plus S plus 1 equals 2 plus S, which equals 2 minus S, right? Just plug this guy into this T. We got this. We simplified to 2 plus S, and that is already equal to 2 minus S. So we could cancel these, and we get that S is equal to negative S. Now there's only one value that's equal to the negative version of itself. That's just 0. Okay? Positive 0 equals negative 0, because 0 is neutral. Okay, so that means if T is equal to S plus 1, and S is 0, then T is equal to 1, right? So these are our values of S and T. So now, if we plug these guys into this last equation that has A, we get 1 plus T, which is 1, equals 2 times S, and S is 0, plus A. So this equals 2 equals A. That's our answer. So that would be option A. Yep, that's right. Okay, now this last one, what value, or what graph below could be described by which, the graph below could be described by which vector valued function? Now my drawing doesn't really do it justice, so I'm going to show you over here on my screen, and you could pause and decide for yourself. Okay. So the one key feature of this graph is that this Z value right here, this is a flat graph. It's in A. It doesn't change its Z value. Its Z value is constant. You could go back and pause and see that it's literally constant. It lies in a flat plane that's at some point on the Z-axis. So that means our Z is going to be equal to a constant. Okay. So that eliminates option A, that eliminates B, that eliminates D. So we're between C and E, right? Now, there's another key feature of this function that we could use to, I guess, distinguish which is the graph and which is not it. We could actually literally just plug in test values. If you look at that point right there, that vector at the very center of that spiral is like 0, 0, k. Okay, that's some height on z. Now, c can't be it, because e to the t is never equal to 0, right? You can get really close to it, but it's never going to hit 0. So c can't be it. E can. So it's got to be e. Right? Because there's no value of t you could plug in here to get 0, 0 constant. So yeah, that's how you figure that one out. Okay. Yeah, I'm going to keep posting these every day. I hope more people watch them, but yeah, I mean, I kind of mainly just want advice, but thank you. All right, see you guys later.